So what we've been doing, if you remember from the beginning, I try to relate all this stuff. So we've done f of x equals like x squared plus 5x plus 6, and that was called standard form. And then I told you a form that you could change it to. Oh, I got you.
Your screen.
I got you. My bad. All right, so I told you that this was f of x, and I said that x squared plus 5x plus 6, this is called standard form, right? And then what we learned is standard form is good for the y-intercept is sitting right here. It's good to tell us what the degree of the polynomial is, like that's 2 degrees. And what you need to know from now on is the degrees also matches up with the possible number of zeros. That actually has to add up to how many zeros we find eventually. So we should have 2 zeros for this one. And what I can do is I can change this to factored form. And what factored form is good for is actually finding the zeros. Zeros are also known as X-intercepts. You need to start getting used to that term. So right here, -3 and -2 would be my X-intercepts, also known as zeros. Now this should all be familiar because this was a parabola, so -3, -2. This thing would intercept like that, and then at 6 it would hit up here. So this graph would look something like that. That's not very good drawing, but whatever. All right. Now what's going to happen is now we're going to have x to the 3rd power, blah, blah, blah. We're going to have x to the 4th power, blah, blah, blah. And what you're supposed to recognize is when you have x to the 3rd power, that means there's a possibility of 3 zeros, X-intercepts. When you have x to the 4th, you're supposed to realize there's going to be a possibility of 4 zeros, which are called X-intercepts. And you'll understand why I keep saying possibly 4. That could be not necessarily exactly 4. You'll see what I'm talking about today as we go throughout this discussion. But what we're eventually going to do is by using the synthetic division that we did, we're going to start off with something in standard form that's to the 4th power, and we're going to break it down into possibly 4 bubbles, which would be called factored form, and then whatever makes each one of these bubbles zeros would be our X-intercepts. So that's kind of the idea of where we're going. And so I'm going to start you off by doing this. If I just asked you what are the zeros to this function, well, what form is this in, Jonah? Remember, I'm going to kick you out of class if you do not respond at all. Destiny. Do you know what form this is? Do you know what form this is in?
No.
Can you name a form?
Standard form.
Okay. Is this in standard form?
No.
No, it is not. The other form was called factored form. This is called factored form, yeah. Destiny. The reason it's in factored form is because we have each one of these things and they are, what are each one of these things doing to each other, Destiny?
They're multiplying.
Right, so that's what factored form is going to look like. Jonah, I'm going to kick you out if you don't respond to me. I don't care if it's by text or by actually unmuting and talking.
He had responded in the chat.
Huh?
He had responded in the chat.
Oh, it didn't show up on mine. All right, I see it now. Mine didn't come up. All right. So when we do this, this is going to give us our zeros because what are each of these? Destiny just said that each one of these things are multiplying to each other. So the zeros, if I think about the X-intercept, where do the X-intercepts happen? Nina, what happens when I'm on the X-intercept? What can I guarantee to be true? If I'm on the x-axis, what do I know to be true?
Is it always 0?
What is always 0?
The x-intercept?
No.
Um,
Think about, so when I do an ordered pair,
oh,
Nina.
y.
Yes, your y is 0 because you haven't gone up or down at all. You are staying right here on that. So that is y is 0. So what did we say f of x stands for? Ashton, what does f of x stand for? What is this really?
Y.
And so when I say I'm finding the x-intercepts, I'm actually saying this is going to be 0. Is everybody understanding what I'm talking about so far?
Yep.
Now, if all of these things are multiplying by each other, there is a rule for multiplication. Austin, do you know the rule for multiplication? Anything times something is 0. Austin?
Yeah.
Anything times?
0 is 0.
So, Austin, this is a number, and it's going to multiply by this number, and then it's going to multiply by this number. Yes, there's 3 numbers. Are you with me?
Yeah.
What happens if this number right here is 0? Do I care about any of these other numbers?
No.
Why? What is this number going to do to this number?
It'll make it a 0.
And then what would it do to this number?
Make it a 0.
So what number would make this first one a 0? What could you put in for x? It's not really a trick question, Austin. I know it is in the beginning, but at the end you kind of go, oh yeah. What would you put in here to make this 0?
0.
There you go. So x equals 0 is the first x-intercept. Comma. One more, Austin. What would make this one 0? What would you put in for x that would make it 0?
4.
Yep. And Daniel, what would you put in for this last one that would make it 0? I can't hear you if you have it. Do you have a mic, Daniel?
-3.
-3. Very good. Now, how many x-intercepts does that give me? That gives me 3 different x-intercepts, which makes sense because if I would FOIL this out or distribute it out and put it in a standard form, remember this is factored form. If I put this in a standard form, it would get me x to the 3rd blah, 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 which would tell me that this is to the 3rd power, which means I should find at 3 zeros, and which I did. 1, 2, 3. Now, what I can do now is I can actually use my end behavior, which since I know kind of the first term, and I know my zeros, I can actually sketch a graph of this. 1, 2, 3, 4 is a 0, 0 is a 0, and 1, 2, 3, -3. Now, because this thing is x to the 3rd, and I know that my coefficient in the beginning is going to be positive, I know that my end behavior is going to be down up, which means this thing is going to start down. It's going to go like this and finish up. So that's kind of a sketch of that. Now, is that perfect? Absolutely not. But that's not, sometimes in math, I'm not going to ask you for the perfect graph of it. I just want the idea. And then you can tell me, hey, between this, between 0 and 4, all your numbers are going to be negative, which means for this, if this was a business, you'd be like, hey, listen, your first 4 years are going to look like you're not going to make a profit. It's going to get rough. Just trust the process, because eventually after year 4, you're going to make so much money, it's going to be worth it. Like, that's how they use these kinds of things in the real life. Does everybody understand how I can kind of sketch a graph using my end behavior and my zeros?
Yeah.
Now, I didn't find the max. I didn't find the mins. By the way, this would be a things we've talked about in the past. This would be a relative maximum. This would be a relative minimum. I didn't find those exact coordinates because, like I said, this was just a sketch. It's just an idea. I know it's something like this. Questions on that? All right, now what can happen is sometimes we have a zero that happens more than once. Isabella, can you tell me one of the zeros?
Yeah.
What would one of the zeros be?
Would it be -2?
No, close though. What would you put in for x here that would make that 0?
1?
What's 1 minus 1? Or what's 1 minus 2? That'd be -1.
Yeah.
What number would I put in here that would make this turn to a 0? What? Minus 2.
Two.
Yes, 2. So 2 is my first one. Okay, so do the same thing here. What would I put in for there to make that become 0?
1.
Okay, so there's my zeros. Okay, very good, thank you. Now the only problem is if I think about this, this would be x minus 2, and then there would be an x minus 2 again, and then I'd have this x minus 1, which means that my power should still be x to the third. Do you guys understand what I mean about if I FOILed this out and I distributed all this crap? I would get x to the third as my highest power, because x times x would be x squared times another x would get me to x to the third. So what I mean by that is there's supposed to be 3 zeros, but here I only found 2. Well, that's because this little squared button, that right there tells me this one actually doesn't count as 1 0. It actually counts as 2. So if I was counting my zeros, this would be 1, 2, and then 3. This one right here has what we call a multiplicity. It has a multiplicity of 2. And now what happens is whenever something has a even multiplicity, it does something weird at the x-intercept. So what happens is I still know that it's positive. I still know that it's the third, so I know it should be down and then up. But watch what happens if I try to do what you guys, if you guys try to draw this, you'd probably go like this and like that. And you go, wait, that doesn't match up, Mr. Martin. It's down, down. How can I only have 2 zeros and me go and, start down and end up like I'm supposed to? I don't understand that. Well, that's because of this multiplicity. What happens at this 2 is it actually hits the x-intercept and bounces right back up. Anytime, please listen, anytime something has a multiplicity of even, an even multiplicity, so this was a multiplicity of 2, it hits the x-axis and bounces right back to where it was. Anytime it is odd, it goes right through the x-intercept. So let's try to practice that. All right, Trey. Trey Hood. Eric.
No, can you
Can you give me a 0?
hear
Yep. Can you give me a 0?
Positive 3.
Perfect.
And then a -2.
Perfect.
And a -7.
Now, can you tell me anything special about this 3, though? Can you use the word I just said? It has a multiplicity. This is something important to understand. It has a multiplicity of
3.
3. The -2 has a what?
Multiplicity of 2.
Yes. And this -7 just has a multiplicity of 1.
1.
So here's what that means. That means if I FOILed this whole thing out, or if I distribute this out, it would become x to the, well, this would be x to the 3rd, this would be x to the 5th, x to the 6th. Notice if you count how many zeros there are, that tells you also the power of this thing at the end. So 3, 4, 5, 6. Does everybody understand how I'm realizing that this is going to be x to the 6th power? This is also going to be a positive times all positive. So this is going to be positive, which means it should start up and end up. So if I asked you to sketch a graph of this using the zeros and the end behavior, you would go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, whatever. -7, 1, 2, 3, 4, 5, 6, 7. -2, 1, 2. 1, 2, 3, and starts up. Now, when it goes to the multiplicity of -7, it's got a multiplicity of 1. That's odd. It's going to go through it. When I go to the -2, it's got a multiplicity of 2, so it's going to hit it and bounce right back down. And then when it goes through the 3, it has a multiplicity of 3, so it's going to keep going through since it's odd. And that would be a sketch of that graph. It looks kind of like a W. Does anyone have any questions on what I am talking about when it comes to that?
So it only bounces back down or up if it's odd.
No, it
If it's-
bounces and goes back when it's even.
When it's
Odd-
even. Okay.
Odd, it goes through.
Okay.
Do you see how the multiplicity here was 1, so it went through? The multiplicity here was 3, so it went through.
Okay.
Multiplicity was even, so it hits and it bounces back down.
Yeah. Okay.
Does that make sense?
Yeah.
All right. So for this one, the question is, what are the real, what is the real 0? And then what they want you to do is they want you to rewrite this in factored form. Okay. Well, it's like we're kind of doing the same thing, but we're doing it in a little backwards. So remember I told you a lot of times I've been giving you in factored form. You've been giving me the zeros and then we're graphing it. Well, I kind of gave you the graph. And now based on that graph, you're going to rewrite this so that it's in factored form. Well, this is called the 0. The 0 is 2. But if you remember back, when I said x plus 2, right, was my bubble, the 0 was -2. So if I gave you the 0 as 2, what does that mean would be in my bubble? What would that mean like this? It's going to be x what?
-2.
Minus 2. So that means if this is a 0, that means that x minus 2 must be a factor of this. So that means I can rewrite it as x minus 2 times something. The problem is I don't know what this something is. How can I figure out how many times this goes into this?
You could use division.
And what kind of division would you like to use?
Could you use synthetic?
Why can we use synthetic?
Because it's a planet.
Because it's just x minus 2. So what would be the thing that I would use in my box would be 2, and then 1, 1, -3, -6, and then we would drop it down. 1 times 2 is 2, 3 times 2 is 6, add together 3, 6, and 0. And why did we think we were going to get a 0? Because this is supposed to be a factor, which means it's supposed to go into it perfectly, which it did. That means that it's x squared, 1x squared, plus 3x, that's the 3, plus 3. I just rewrote this from standard form into its factored form because I knew this information. And actually, it won't be factored anymore, because if it could be factored anymore, there would have been other x-intercepts. Because this never touches the other x-intercepts, I know those other intercepts must be imaginary. Try this again. I want you to rewrite this in factored form, and I'm going to give you this information. So I want you to rewrite this based on the information that I just gave you. All right, Sierra. Because I told you this information, what do you know?
Well, it's an odd number, so it would be like x minus 3.
So what I'm going to divide by, yes, it's not because it's an odd number, but you did it right. It's because 3 is the 0, so that means that x minus 3 must be the factor. So that means I can rewrite this as x minus 3. The problem is I don't know what the rest of the junk is, so that's when I use my synthetic division, which is from the last section, right? That's what math does, right? We teach you something. The reason we have to teach it to you is because we're probably going to use it later on after, right? So from everything that we've ever done, it's probably going to come back up at some point. So we're going to put 3 here. Sierra, what's going to go next for my long division or for my synthetic?
2.
Yep.
Negative 8.
Yep.
9.
Yep.
And then negative 9.
Perfect. Drop down the 2. 6. Is this what you got?
Yeah.
Negative 2. Negative 6. 3. 9. 0. And then we would get in here 2x squared minus 2x plus 3. And then sometimes eventually what's going to happen is you see how this right here, this sucker is to the 3rd power. Well, eventually this thing might actually be able to be factored again. But if it would be able to be factored again, I would have seen more intercepts up here. And when I would have been able to write that. But since it doesn't have any more intercepts, this guy, if someone ever asked me to find the other zeros, I would have to use that quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I can use a quadratic formula for this guy because it's now quadratic. I'm only using this piece of it. This would be my a, there's my b, there's my c. I'd plug all those into this over here, and I could find the other 0, which they would probably be imaginary, because that's why this thing doesn't run into the x-axis, but only once, because the other intercepts aren't real. They're imaginary. Does that kind of make sense to you?
Yeah.
The biggest thing that we wanted to cover today was that multiplicity, understanding if something has a multiplicity that's even, it's going to bounce. If it's odd, it's going to go through. This idea of using the zeros, something being in factored form, and that multiplication by 0 rule, making sure we understand those things. Is there any questions on any of that so far?
No.
Sketch a graph of that. Now, it is easy because it's all in factored form. Eventually, when we get to 3/6, it's not going to be in factored form. I'm going to have to teach you a whole process to try to take something that's in standard form and take it back to a factored form. Tucker, give me a 0.
3, negative
Perfect.
2, and 4.
Can you give me the multiplicity? Tucker?
Yeah. No, never mind. I forgot.
Okay, well, so listen. The multiplicity has to do with this power that's attached to that. So this has a multiplicity. Do you see where this is where the 3 came from? So it has a multiplicity of 2.
2.
Okay, what is the multiplicity of the negative 2?
2.
And what is the multiplicity of this one?
3.
Now, when you add up all the multiplicities, that will tell you the power of the x if it was in standard form. That would give you what power this would be to in standard form. So 2, 4, 7. So this is going to be x to the 7th power, which I need to think about that because that tells me it's odd. And then I know it's going to be positive because all these things are going to multiply by positive. So I know it's down, up for my graph. 1, 2, 1, 2, 3, 4, down. So it starts from the down. It goes to this one at negative 2. Since it has a multiplicity of 2, it's going to hit and bounce back down. Here it's going to hit and, since it has a multiplicity of 2, bounce back down and then go through. Again, that's just a sketch of that graph. That is not perfect for exactly what happens, but it's close enough. If you can understand that problem, you should be pretty good for what we need to get going. We're going to get started right when we get back, probably on 3-6, and hammer it out to get ready for that other test. So you have a 1 to 3-4 test tomorrow. We will hammer 3-5 and 3-6 when we get back, and you will have a final test of 3-5 to 3-6 that last week. Don't forget to keep working on that exam review, as that is also a massive grade, and you also have 1 retake. So you can go going back over that stuff. Other than that, that's all I have. If you have any questions, let me know.
Have a great day.
Thank you too.